Applications of binary search. So binary search has numerous applications. Searching a dictionary or searching a telephone directory, finding the smallest and biggest in a sorted list, and etc. Hashing is a technique which can be used to know the presence of a key in a list in just one step. So we use a hash function, takes the elements of a list one by one and generates an index value for every element. And we will generate a new list called hash table. Each index of the hash table can hold only one item. The positions are indexed by integer values starting from 0. The size of the hash table can be larger than the size of the list. So a hash function takes elements of a list one by one and generates an index value. A simple hash function that works with numeric values is known as the remainder method. It takes an element from a list and divides it by the size of the hash table. The remainder so generated is called the hash value. So look at an empty hash table with 10 positions. The index starts with 0 to 9 and the value is none. So we'll see an example here. A list of numbers 34, 16, 2, 93, 80, 77, 51. So we can use the hash function remainder technique to create a hash table. So what is the element 34? See, we created a hash table with 10 elements. So each and every element mod 10. The mod 10 applied on the elements of the list. So 34 mod 10 is 4, 16 mod 10 6, 2 mod 10 2, 93 mod 10 is 3, and 80 mod 10 is 0, 77 mod 10 is 7, and 51 mod 10 is 1. So we have hash values. Each element is inserted at its designated position in the table. So look at 80. 80 mod 10 is 0. So at index 0, 80 is inserted. 51 mod 10 is 1. So at index 1, 51 is inserted. 2 mod 10 is 2. So it is inserted at index 2. 93 mod 10 is 3. So 93 is inserted at index 3 and so on. So why mod 10? As I told you, we created an empty hash table with 10 elements, indexed from 0 to 9, and the value is none. Now the given values are inserted into the hash table based on that remainder method. So if you want to search for a key, we can calculate its index using hashing function and compare the element at that index with the key to declare whether the element is present in the list or not. For example, I am searching for 34. So 34 mod 10 is 4. So search the element at index 4 only. So here in the table index 4, the element is 34 and we are searching for 34, element is found. I am searching for 71. 71 mod 10 is 1. So what is the value at index 151? Only compare with that value only. So at index 1 we have 51. I am searching for 71. Both are not same, so element is not found. This involves just only one comparison. The same amount of time is always required to search a key irrespective of the size of the list. That is the advantage here. So what if I have more than one element with mod 10 gets the same index position? For example, I have 51, 51 mod 10 is index 1. If I have 61, 61 mod 10 also index 1. So this is called collision. We will be discussing regarding the collision technique later. So we have a Python program. The function to check if a key is present or not. So what is the name of the function? Hash find. Two parameters to be passed. One is the key and the other one is hash table. So look at the selected one. You are creating a hash table with 10 empty position. Hash table is equal to none, none, none. And we are printing the hash table. So now we have a list with 34, 16, 2, 93, 80, 77 and 51. You are printing the given list. So first thing is we need to apply hash function. So look at that for loop. For I in range 0, len, length of the list, hash table L of I mod 10. So each and every element mod 10, you are putting in L of I, the same list. So the hash table contents are displayed. Now you are searching for the key. Enter the number to be searched. So look at the function call. This is your function call, hash find key comma hash table. So we'll just go back and see the function definition part. So look at hash find. If hash table key mod 10 is equal to key, so what is key mod 10? I am searching for 51. So 51 mod 10 is 1. So hash table of 1 gets the data in the first index. If it is equal to key, then you are returning the position. Otherwise, if the key is not present, return none. Look at the example there. In index 1, I have 51. I have 51 in index 1. I am searching for 51. So key is 51 and hash table of 51 mod 10 is 1. So hash table of 1 is equal to key. Hash table of 1 is 51 and 51 is equal to 51 is true. You are retaining the position. So if position is none, so key is not present, otherwise key is present.